Hello again, math friends. Today we're going to take a look at factoring the greatest common factor. This will also help us with what else we're going to cover today, which is factoring by grouping. So first of all, let's talk about the greatest common factor. It's the largest number that is a factor of all the numbers in your set. So let's kind of go back and do some review. If we want to find the greatest common factor of a set of numbers, we look at those numbers and we factor those numbers. So I'm going to take 20 and I'm going to factor it into its prime numbers. I know it's 5 times 4. 5 is prime. 4 is 2 times 2. Those are prime. So 20 factored down into primes is 2 times 2 times 5. 12 is 4 times 3. We know 3 is prime. 4 is 2 times 2. So 12 is 2 times 2 times 3. So to find the greatest common factor, we look for what factors are in both, in this case, both numbers. We have a 2 in both, but we also have another 2 in both. So the greatest common factor of 20 and 12 is 2 times 2, which is 4. And what that means is 4 is the largest number that will go into or divide into 20 and into 12. Let's look at the greatest common factor for 6, 8, and 10. 6 is 2 times 3. Those are both prime, so we don't go any further. 8 is 4 times 2. 2 is prime. 4 is 2 times 2. So 8 is really 2 times 2 times 2. 10 is 2 times 5. So the factor that's in all three of these numbers is 2. There aren't any other factors that are in all three numbers. So in this case, our greatest common factor is 2. Let's take a look at the greatest common factor for 20 and 15. If we take 20, 20 is 2 times 10. 2 is prime. 10 is 2 times 5. So 20 is 2 times 2 times 5. 15 is 3 times 5. Those are both prime. 3 times 5. And 10 is 2 times 5. So the factor that is in all three of these, in this case, is just a 5. So the greatest common factor is 5. Now let's see how to apply this in rational expressions. So if you look, we've got 3x plus 6y minus 12z. I need to look at each of these terms and look to see if there is something that will divide into all three of those terms. And the largest thing that will divide into 3x, 6y, and 12z is 3. So I'm going to factor out or divide out. Remember, the word factor means to divide. Or factor out means to divide. So if we're going to factor out or divide out a 3, then I would have an x left. 3x divided by 3 is x. And 3 times x, when we use distributive property, gives us 3x. If we divide out a 3 from 6y, we get 2y. And if we divide out a 3 from 12z, we get 4z. If I use distributive property and distribute the 3 over the x, the 2y, and the 4z, I will get 3x plus 6y minus 4z. So it's sort of undoing the distributive property. The greatest common factor may not always just be a constant. It may be a variable. If we look at x cubed plus 3x squared minus 4x, I can factor out or divide out an x from all three of those terms. If I take x cubed and divide out an x, I'm left with x squared. If I take 3x squared and divide it by x, I get 3x. And if I take 4x and divide it by an x, I get 4. If I redistribute this, x times x squared is x cubed, x times 3x is 3x squared, and x times -4 is -4x. All right, let's take a look at this one. This time we have a 9x to the 5th plus 12x to the 4th minus 6x squared. So I know that I can take an x squared and divide it out of all of those, but if I have a 9, a 12, and a 6, the largest number that I can factor out of that would be a 3. If I take 9x to the 5th and divide it by 3x squared, I get 3x to the 3rd. X squared times x to the 3rd is x to the 5th. 3 times 3 is 9. Plus, if I divide a 3 out of 12, x to the 4th, I get 4x squared. 3 times 4 is 12. X squared times x squared is x to the 4th. Minus, if I take and factor out, divide out a 3x squared from here, I get 2. -2 times 3x squared is -6x squared. Let's take a look down here. We need to look at each of our terms. And I know that, 12 will go into 24, 12 goes into 12, 12 goes into 36. So I'm going to factor out a 12. And then I've got an x cubed, x to the 4th, and x squared. The most I could take out of all three of those terms is an x squared. I have a y squared, a y cubed, and a y squared. So the most I can take out is y squared. So if I divide this first term by 12x squared y squared, I get 2. 12 times 2 is 24. If we divide out an x squared from x cubed, we're left with an x. And if we divide out the y squares, they completely divide out, and we're left with just 2x. 12x squared y squared multiplied by 2x is 24x cubed y squared. Minus, here we're dividing out the 12s. We're going to divide out x squared from x to the 4th. We're left with x squared. X squared times x squared is x to the 4th. And divide out a y squared, we're left with y. 12 times -1 is -12. X squared times x squared is x to the 4th. Y squared times y is y cubed. Plus 36. 12 goes into 36 3 times. We're dividing out an x squared. There's no x's left. We divide out the y squares. They're divided out. So 12x squared y squared times 3 gives us the 36x squared y squared. All right, let's take a look at this one. So this time we need to look at all of these terms, the 4 terms, and we can see that we can take an x squared out, but let's see, I've got a 9, 18, 27, 45. I can divide out a 9 out of all 4 of those and an x squared. So if I divide out a 9 from, or 9x squared from 9x to the 5th, I get x cubed, because 9 times x squared is 9x to the 5th. Minus, now we divide 9 into 18, we get 2. Divide out x squared from x to the 4th, we're left with x squared. 9x squared times -2x squared is -18x to the 4th. Plus 3. 9 times 3 is 27. We factor out an x squared, we're left with x. 9x squared times 3x is 27x to the 3rd. Plus, then we're going to divide out 9 from 45. We get 5. And we divide out the x squares. And so 9x squared times 5 is 45x squared. Now let's apply what we have learned to a different situation. We need to remember that factors are the numbers that we multiply together to get another number. Remember earlier when I was factoring 20, and I said 20 was 4 times 5, and 4 was 2 times 2. 4 and 5 are factors of 20. 2 times 2 times 5 are factors of 20. When we look here, 2 and 3 are factors of 6. We multiply those together to get 6. 3x and y are factors of 3xy. And x plus 1 times x minus 3 are factors of this trinomial. If we use FOIL method or distributive, x times x is x squared, x times negative 3 is a negative 3x, positive 1 times x is plus x, that gives us our negative 2x, and positive 1 times negative 3 is negative 3. So x plus 1 and x minus 3 are factors of x squared minus 2x minus 3. We're going to need that in order to simplify or factor problems that look like this. So the first thing we need to notice here is that this right here is multiplied together. Those two binomials are multiplied together, and we're subtracting this set of multiplied binomials. But I can do a little bit of magic here by taking this binomial and factoring it out. If I do that there, I have to do it here too. So I'm dividing it out of the first term and the second term, just like we did earlier when we were dividing out a particular factor from each of the terms. And when I do this, what's left is the x plus 4 term minus this x plus 5 term. If I were to distribute this again, I'd have x minus 6 times x plus 4, which was what was up here, and x minus 6 times negative x plus 5 is minus x plus 5 times x minus 6. We just factored that out, and this is what's left. But in here, we can do some simplifying. We have x plus 4. This negative needs to be distributed, so we get negative x minus 5. And so this becomes x minus 6 times, the x's add out, 4 and negative 5 is negative 1. So we get negative 1 times x minus 6. We could leave that as an answer. We could distribute the negative and get negative x plus 6. If we were to do that, we would probably clean that up a little bit and write it as 6 minus x. So this or this or this would be correct answers. But this is called factoring by grouping. We take and group some factors together and factor out something from that group. Okay, here's another example. We need to realize that all of this is being multiplied together. All of this is being multiplied together. The thing that is common to this set and this set is the x plus 2. So if I take the x plus 2 and take it out, I have to take it out from both. Then we look at what's left. So what ends up being left is x squared times x minus 4 minus x times x minus 9. So you sort of visually take that factor out of each of the sets, and when we do, we look at what's left over once we factor out the term that, or the factor that we divided out. So here we need to do some simplifying. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. We have a negative x to distribute. Negative x times x is negative x squared. Negative x times negative 9 is positive 9x. So simplify what's inside. X cubed, negative 4x squared, and negative x squared is negative 5x squared plus 9x. And since we are factoring, we can factor an x out of here. We could have done that at the beginning. I should have seen that we could have also factored out an x from both terms, but it's okay to do it here. So if we go ahead and do it here, we're going to factor that x out. Factor an x out of here, and then we're left with x squared. Factor an x out from here, we're left with the negative 5x. And factor an x out from here, we're left with 9. So this original expression can be factored down and broken down into x times x plus 2 times x squared minus 5x plus 9. All right, here's another example. We've got a x plus 4 in both terms, but actually we have an x plus 4 squared that's in both of those. So I'm going to take the x plus 4 squared out, and when I take that squared out of this term, we're left with an x plus 4 to the first. Okay, see again, we had it cubed, but if we take 2 of those out, then we are left with 1. So the stuff that's left is x plus 4 times x minus 1 minus x plus 3. So x plus 4 squared. So x plus 4 squared times x plus 4 times x minus 1 would give us that x plus 4 cubed minus x times x minus 1, and the x plus 4 squared times the negative x cubed would give us the x plus 4 squared plus x plus 3. Do some simplifying inside of here, so we need to multiply these two binomials together. We get x squared, we get a negative x and a 4x, that's plus 3x, and 4 times negative 1 is negative 4. Distribute this negative, we get negative x minus 3, and so this is x plus 4 squared times x squared, and 3x and negative x is 2x, and negative 4 and negative 3 are negative 7. So this original expression would factor into this. Okay, hopefully you have learned something from this. Thanks for watching, and we'll see you on the next episode. Bye now.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.